let's just start off at least setting up the graphs and getting an idea of how we would graph and transform them, and then we'll graph a few. So first off, the most important thing that you guys need to remember is exponents and logs, they are inverses of each other. And we learned with inverses, everything with inverses on the x's gets to swap out with the y's. Everything. That means like domain and range will swap out. That means like if on my original function f of x, if I have a value at say like a, b, then that means an inverse. So we use a little superscript for inverse. We kind of did inverses back in, gosh, what unit did we talk about inverses? Like the inverse of a function. We found the graphs and we swapped the x's and y's. I think it was unit 1 or 2. If you guys remember. Unit 2. So those of you who were here for unit 2 or with us, and I think Honors still did unit 2 in some way, but the inverses would just simply switch out the a and the b to have just those coordinates. And if you guys remember when they were graphed, they were reflective over the line y equals x. Like I can sit there and fold them over that line and they line up. Do you guys remember all this when we learned about inverses just a little bit? Now since everything with the x's and y's is swapped, it's the same thing with domain and range. So for instance, my domain and range on f will match, I don't know why I switched it. So when we find domain and range on both, this domain will match this one's range. And this one's range will match that one's domain. And we're going to kind of set this up and be able to kind of recognize that. So everything about them is swapped out. So with that being said, let's just set up what a growth looked like for exponents on 6-1 and then see how that relates to the logs. And then we're going to do a decay, and we're going to try to do all of that. All right, I'll try to be as quick as I can, but I want you to wrap your head around it. So I'm sorry if it drags out just a titch, okay? So here's an example. So a growth on exponents was when the b on the b to the x was above a 1. So a growth on a log would also have a base that would be above 1, okay? And the direction and the shape. This one came along an asymptote and then took off. So the same thing on this one. It comes from the negative opposite direction on y and it takes off a little bit. So they have similar properties. Now to make this graph a little bit easier, we're going to be graphing here, and then this is the graph we're actually setting up. So this is all review on this side. All right, let's just work with a 2 to the x for easy numbers instead of just a b. And we already have these parent values on our notes, don't we? And we are also going to talk about how we have a horizontal asymptote, how we have the domain, and we have the range, and then we're going to do our parent function over here, okay? So we're going to also talk about like what these ordered pairs would look like, and we're going to talk about what type of an asymptote it has. We're going to talk about this one's domain and this one's range and just see how it transfers, okay? You're not always going to have to start here to graph this. I just think it's a good place to begin, okay? So this is the graph you guys are emphasizing. This is the parent, and we will be graphing a log base 2 for easy numbers instead of just using a b. Okay, let's set this up. What pattern did we develop when we had a b raised to an x? We would plug in which 3 points, the easiest ones?
-1, 0, 1.
Yep, -1, 0, and 1. That's the pattern we learned, right? And a 2 to a -1 is a 1/2. A 2 to the 0, is a 1. And a 2 to the 1 was 2. And didn't we have a horizontal asymptote at y equals 0? Good. And then what was the domain on exponential functions?
All real numbers.
Yeah, all reals. And what was the range?
Positive.
Positives, which we're going to say 0 to infinity. So let's plug in these values. And again, this is already in your notes, so don't think that this is the graph for the logs, okay? We're still doing exponents. But I think if you understand where we're coming from, you'll understand our graphs a little better. Making connections to prior knowledge is kind of key here. We remember doing this, right? So everything with exponents, if this is a base 2 and that's a base 2, is going to be swapped out, okay? So give me some coordinates you think you would find if you photograph a log base 2.
Negative. Oh no, it'll be 1/2.
1/2 negative 1. 1, 0. 2, 1. You guys don't have to start here though to get this. I just want that to be clear. Like, since we got so good at evaluating functions, you guys can also just plug in the first few that make sense. And we can do them by hand. You could plug in, I'm not going to plug in 1/2. Let's go to the ones that are like just nicer. If I plug in a 1, we're used to when we log a 1, what happens?
0.
It's a 0. And then if I plug in a 2, I have a 1. If I plug in a 3, that's not a whole number. So what's another one we could choose?
4.
4. And so what would be the log?
2.
Yep, log base 2 of 4, which is 2 squared, is 2. So you could do those 3 values instead of the 1/2, okay? But this is just a good way to see where this graph comes from. It's just the inverse of those. If this has a horizontal asymptote at y equals 0, what do you think we have on this one?
Vertical 0.
Verticals, yep. At, what'd you say, Eric?
X
X equals
equals 0.
0, because you got to switch your x's and your y's. Do you guys remember learning that we can't log 0? And you remember learning that we can't log negatives? Do you guys remember that? How we talked about last time? There was a property in your notes, and we learned that if I try to log a base b of some sort of negative number, we learned that b to the x will never end up to be a negative number, right? Never. We learned that. We learned that if you try to log a negative, it doesn't work. If you try to log a 0, it doesn't work. And the reason for that is because when you guys look at this graph, there's an asymptote at 0, and you will only find values on this side. So there's like a domain restriction on these ones. Let's actually talk about that domain. This domain was negative infinity to infinity. So what do you think that's going to match over here?
It would be domain 0, negative, and then range is all.
Careful, 0 to infinity, and then range is all rails. Good. 0 to infinity. That domain is this one's range, and then this one's range matches that one's domain. Okay? So your graph is going to run somewhere from 0 to infinity. Let's just see what these points look like. 1/2, negative 1, 1, 0, 2, 1, and we're over here at 4, 2. So it comes along from negative infinity and then kind of essentially takes off, right? All right, do you guys see that they look like inverses? In fact, if I drew that over here, I'm going to draw it over here in just yellow so you realize it's kind of extra. Do you guys see how they're inverses of each other? And it looks like if I could fold them over this line y equals x. Do you guys agree with that? So that is the parent function, and that is if the b is above 1, okay? So what do you guys think will happen to this graph if my b is like a 1/2 instead?
It's
like
going to go to the other side, flip.
Not the other side, that's a good idea. It's not going to be the other side, it's going to be...
Oh, okay. So it's going to, like, the one's going on the 0 is going to be above, and the one's going away.
Good.
It's going to go
We'll be going like that,
yeah.
which we're going to set it up. Let me hear you talk about this. How can I generate these parent values without starting here? Because that's just a lot of work. You guys are more than welcome to take this negative 1, 0, and 1 and put them in the y's. Negative 1, 0, and 1. And you guys are actually welcome to plug them into the y's and then get the x's. Isn't that kind of an interesting, like, backwards way of doing things? I can sit there and say, I'm used to saying negative 1, whatever, and I can plug it in. So let's just start here, for instance. I could plug in a 0 to my y and then solve for x because we know how to do the around the world. I can say, hey, 2, I can convert it. 2 to the 0 is x. Oh, that's a 1. I got a 1 right here. So you guys could plug your pattern that you did on the x's here into the y's. That's one approach. I know Taylor teaches it that way. You could just be strategic on what you plugged in like we just did. Plug in a 1, plug in a 2, plug in a 4. Okay? Now next we're also going to discuss mapping. So it's not like you can still map for those of you who are kind of like mappers when you go to graph. Let's draw what a decay looks like. I'm not going to be as thorough. We're mainly just going to like whip through it to get it down on our notes. And then we're going to talk about, just so it's in our notes, and then talk about transformations really, really fast, okay? So let's just kind of get a sketch. Okay, so this is if, remember how it was a decay on exponential models? I meant just do a b. When our b is between 0 and 1, okay? So those values, when I plug in a negative 1, 0, and 1, we're now at 2, 1, and 1/2, right? And same domain and range. Nothing's changing with our domain and range. Your range was 0 to infinity. We still had the horizontal asymptote even on decay functions. And I think that's all we really need to hurry and set up. So we have our domain and range. We had these be a decay this time. And so here is what your graph essentially looked like, which this should be in your notes. So you don't have to like repeat that if you don't want to. Now, if I choose to have my log, let's just do this one's inverse. And again, your b is between 0 and 1. So we're going to get the parent values for a 1/2 log. So don't be thrown off. You guys could just flip all those values and rewrite them here. So I'll have a value at now 2, negative 1. I'll have a value now at 1, 0. I'll have a value at like 1/2, 1. But you could have also said, what is it 2? Oh, negative 1. What is the log of 1? Oh, 0. What is the log of 1/2? Oh, 1. What is the log of 4? We could plug in more. What's the log of 4? What do I do if I plug in a 4 there? Log of 1/2 and 4. I can turn the 4 into a 2 what? 2 squared. And then I can make that 2 a 1/2. So I could essentially rewrite this as a log base 1/2 of 1/2 to the negative 2, right? So you guys can be strategic on how you build these values, okay? Anyway, when we go to look at this on the graph, and we have our vertical asymptote still at x equals 0, just like the growth one, domain is going to match up there because it's now 0 to infinity. So notice how nothing switched. Like, these graphs are nearly identical besides which direction that they go along the asymptote. So we had a value here now up here, here, 2, negative 1, 4, negative 2, and so Ty was exactly right. It's now going along the asymptote the opposite direction. It just looks like, so this is what a decay, a base 1/2 looks like, and up there was what a base bigger than 1 looked like, okay? That's the boring part. I know it's been boring. We had to set it up, but now let's make sure we know how to get values if we want to, do the mapping if we want to, find the domain if we want to. So we're going to go through all those key details. Let's hurry and do some transformations. I hope transformations are so easy for you now that you're just like almost bored with them, okay? So remember, anything in the function, anything outside the function affects the y. Anything in the function is the x's. So let's hurry and decide what affects the y first, and then we'll affect the x's. Does that work? Mm-hmm. What did the plus and minus do again? It negates our...
Then it goes up, then it goes increase or decrease.
Good. It reflects over our what axis?
X-axis.
X-axis reflection. Perfect. Okay. And then this video will be posted if you struggle with the rest of it. But for the most part, you now know the graph, so you should hopefully and have a good long weekend. So let's go and talk about a growth one. If that's reflected over the x-axis, what does it look like? Looks like a what now? Decay, right? Does this affect the domain? No, no, it didn't, because look at, did it stay 0 to infinity? Mm-hmm. Yes. Did it affect the range? So that change didn't really change anything, just the values, right? Okay. What does the A affect again? Also
stretching and compose.
Yep, it is our vertical kind of like stretch or like a shrink or compression, depending on how you guys want to view that, right? So shrink or compression. So it will affect our y's still. So here's what an idea looks like. Here's what a typical growth function looks like. Let me show you a stretch. If there was like an A out front, it looks like this. So this is like if your A is above 1, okay? If your A is a fraction, like below 1, it would maybe kind of turn like that. That is if your A is below 1. That's what a vertical stretch and compression looks like on these ones. Let's continue helping switch the y's. What's this one again, the up and the down? Vertical shifting, right? What does vertical shifting affect as far as the mapping goes? Your y's, right? This will affect our y's. So will this one affect domain and range? If this is my parent and then let's say it moves, let's say I have a +3 on it and it's like moves it up. Or if I have a -5 or something and it moves it down. Did it affect my domain and range? So are you noticing so far anything that affects the y's did not affect my domain or range? Okay. Okay, now let's get into the x's, which I'm going to switch colors to maybe orange. Let's erase this though, right there. All right, this affects a lot, okay? It is our horizontal shift, which we're pretty used to. And we're also used to x's lying and y's tell the truth, okay? So that will move my x's where? If it's an x minus h, it moves it plus h. What else moves? What else is affected? If I choose to move all my x's, meaning this, if I moved all my x's, say right h, what did I just move? Yeah, I moved my asymptote. It moves your vertical asymptote, and it affects the domain. It affects both those things, okay? Because I just shifted my asymptote left or right. So this one changes quite a bit as far as like the other details of your graph. Cool? You guys hanging in there? Should we do like a brain break? Someone give me, like, should we stand up and move for a second? Because 8th period is so hard. So back from a little brain break, we are going to talk about, so your front page asks these pieces. It wants domain. It wants to be able to graph it, so we're going to be able to find the vertical asymptote. We're going to be able to refresh your memory on mapping. So we'll start with a parent and then map it. And then we'll start with another parent and then map it. And then we'll do something your assignment. Okay? Okay. First off, what if you guys don't know how to strategically, as we get these parent values to graph, because we already have practiced this -1, oh, sorry, it's a log, my bad. This -1, 0, and 1 property or whatever, we have that pattern, you guys can do it by, or you can be strategic on what you plug in. What's the strategic values? Yes, but I just saw you talking to Buddy, so get back quickly, please. What do you strategically, what would you plug into this log base 2 that's strategic?
1, 2, 4.
1, 2, 4. And the reason is because when I plug in a 1, logging a 1 is easily a 0. When I plug in a 2, this would be a 2 to the 1. A log undoes the 2, and so your output is a 1. And then the reason why we didn't do 3 is because it's decimal, so a 4 is strategic. If I plug in a 4, it can be rewritten as a 2 what? 2 squared, so my output is a 2. Does that make sense? But what if I want to plug in a 3 because it's the easiest ones? It's the ones closest to the asymptote. We knew this change of base formula. So if I did want to know what the log base 2 of 3 is, how can that go into my calculator? Because it's not like it's impossible for you to get an output. How would a log base 2 of 3 go in my calculator if I wanted to that those be my values?
Log 3.
I heard it.
Log 2.
Yep, log of 3 would be on top because you use the log in your calculator over log of 2. And you need to make sure you close the parentheses or press equal. You can also do ln of 3 over ln of 2. They're both the same thing. So if you absolutely want that decimal, sure, go ahead and get the decimal, okay? Now we already have this on the other side on your notes because we have been kind of killing these same values like with the base 2 because they're the easiest. So we kind of already have these. So I'm just going to kind of save us the misery of us talking about it for a second. Okay, so if this was our value, parent value, would you guys know how to map those onto that? Okay, so let's go ahead and do it. What would be the mapping, like what values are being affected when you do that? No, nothing on your x's, but my y's are what?
Y plus 1.
My y's move up 1, right? So I would have my values at 1. Oh, sorry. I'm trying to move up 1. I mean, not move up 1. Not change those. 1, 2, and 4 we had used, but my y's all moved up 1. So 0 moved up 1, 1 moved up 1, and then the 2 moved up 1 to 3. So we just moved everything up 1. Did my domain and range switch at all? Did I move anywhere to change either of these? Moving up 1 does not change it, right? I kept these the same. Did my vertical asymptote change? at all? Just by moving my values up 1? No. We did not change our vertical asymptote. We just simply moved up a little bit. And so we have these values. We're over here at 4, 3. Nothing changed, and then could you guys handle the mapping? So do you guys feel like you guys could map some of those and handle your x, y, and what affects what? I'm going to go ahead and talk about this one really quick. And I might even just like skip. Let's just do this one. Let's jump down to D, okay? So first off, I want to talk about domain in a couple of different ways. You guys can calculate domain graphically or algebraically. So I want to show both, okay? Because your homework has you realize vertical asymptotes and domain, and I want to talk about it. Graphically, this is a what shift when I think about this graphically and I'm stating the domain. What shift is this? It's a right 2. So I'm visualizing my vertical asymptote being moved to the right 2. So my vertical asymptote is at x equals what? 2. So that's me doing that kind of like graphically. I realize that I'm moving everything to the right 2. So domain-wise, how would I do that in interval notation since I know that I moved to the right 2? I would say what? 2 to infinity now. Which makes sense to me because am I allowed to plug in a 1 or would that end up being a negative number inside?
Negative.
It'd be a negative number inside. So it means my domain moved. My domain moved to 2 to infinity instead of 0 to infinity. Does that make sense to everybody? Okay. You guys can also calculate domain algebraically. Are you guys noticing back in the parent function, we were not allowed to plug in a 0 or negatives. So x had to stay above 0 on all of it. Well, that means inside here, x minus 2 has to stay above 0. So you guys can calculate domain algebraically. You don't always have to have a graph. And so when I add a 2 over, I can say x has to stay above 2. That is set notation, and then interval notation is 2 to infinity. So you guys can get domain multiple ways. Okay, you don't always have to like visually get a graph. So your guys' bottom homework on like 10 through 13, feel free just to know, hey, I can do this algebraically. Okay? All right, let's hurry and do the mapping and then call it good. My x's all move where? Right 2, and my y's all move up 1. So we would take all of our parent values. Let me zoom just a little so I can see my parent values. We would take all of our parent values for a 2 to the x and do those shifts. So I was at 1, and I'm going to move to the right 2, so we're now going to be at 3. I was at 2, I'm now going to be at 4. I was at 4, and now I'm going to be at 6. Now I'm going to move all those up 1. 1, 2, and 3. So we would have these values to plot, okay? And we're capable of plotting, so I'm rushing this part because I feel like we're pretty solid at this. All right, do you guys feel pretty confident in these problems to try them? Okay, let's give you a head start on your homework and call it good. I want to do one from every section. That way you guys feel like, and you can tune me out. If you'd rather tune me out and just work, tune me out and just work. I'm okay with that. But I'm going to do some from every section, okay? Let's go ahead and do you guys want to do number 2?
Sure.
Okay, number 2 is having you guys
That one fell.
I know. Do you think I need to go see if they're okay? Like someone just ate it. Okay, X, this is a sideways T-chart. And we used to give you numbers, but now we're trying to make you guys kind of have a little bit like the ability to kind of like generate them yourself. I think we're only making you do 3.
Yep.
So give me some ones that you guys would choose to plug in. And this is for you guys practicing generating your own parent values without any transformations. Okay, go ahead.
Y's would be like -101.
So you're going to do that way. You're going to do this strategy. He's using the backwards strategy where he chooses to plug in y's. That's great. Let's actually do both strategies. That way we feel like the ones who don't do this way, we also cater to you. Okay? So he's choosing this and then choosing to plug those into the y's. So he's going to do -1 is equal to a log base 1/6 of x, right? A 0 is equal to a log base 1/6 of x. And a 1 is equal to a log base 1/6 of x, right? So that's fine. We can sit there and calculate those. All right, let's just do, let's do this. 1/6 when converted, would be raised to a negative 1, which is x. So when I reciprocate it, x will be what?
6.
6. Good.
So it's just the opposite.
It's just the opposite. What are we going to get here when I do the 0? 1/6 to the 0 is x. So 1. 1/6 to the 1 is x. So 1/6. So he's choosing the backwards way by plugging into y's. Let's do the other way where we're strategic on what values we want to plug in. So I'm going to plug in x's. Give me something nice. That would work nice if I go to plug it in. And yours don't have to match my key perfectly. What do you guys think?
Can you?
We can do a 1/6, but I'm gonna do 3 doesn't work nice because I can't rewrite the base.
6.
So always start with a 1.
Oh.
1 is the easiest parent value because it'll always give you a what?
0.
A 0. What's the next easiest one?
6.
6. If I plug in a 6 and that's a log base 1/6 of 6, I gotta turn the 6 into a 1/6. So if I do that, what does that do to my exponent? Negative 1, right?
And then you can do like 12?
No. We want to do a multiple of 6. 36 is the next best one, but you could do anything. We could even do a 5 and get a or 7 and get like a decimal. Okay, you really can get decimals. You're not like not allowed to get decimals. If I plug in a 36 though, I could have gotten a log base 1/6 of 36, and I can rewrite that 36 to be a what? 6 squared, and then if I rewrite that 6 to be a 1/6, it makes that square to be a negative 2. So we could get values that way too. I could have also plugged in a 1/6. If I would have plugged in a 1/6, I would have got a 1. So that's an easy value too. So you guys can generate whatever values make sense to you. You don't have to copy my values. Do you guys feel pretty good about trying that? Okay, now let's do some mapping. The next part of your assignments, numbers 4 through 9. We're going to map a few. Luckily, do you guys notice how number 1 is a log base 3 and number 4 is a log base 3? So there's some parent values. And then do you guys notice number 3 is a log base 2? And we ask a log base 2 on number 7. So those kind of give you some hints. Yeah?
What would you do on number 5?
Should we do it?
There isn't a base.
That's what we learned this last time, so let's help my absent kids. What is a log when there is no base?
Oh,
It's a base 10. And so luckily, those ones you can plug directly in your calculator. You don't have to use a change of base formula or anything. Is there one specific that you guys want me to do? Let's try one where the parent values aren't listed above. We could do 5, we could do 6, we could do 8, or we could do 9.
6.
6, does that look like the worst? Okay, let's do 6 together. So on these ones, we're asking for the mapping, and then we're asking for some parent values to be mapped. So it's kind of a lot of work, but, oh, that's a 1/5, isn't it? Did I copy this right? Is this the same one?
Yeah.
That's a 1/5. Okay, let's do it. So first off, what would be the parent if we're going to use mapping, since this one's practicing the mapping way? Okay, the other way was practicing the plug-in way and getting parent value, but let's do this way. If I don't already have my parent values developed, I have to kind of like start them myself. So do you guys recognize that this would be the parent? Okay, so let's write down our patterns. You guys are getting your patterns your own way, just like 1 through 3. Ty does them backwards by plugging in a negative 1, 0, 1 to the y's. We might be strategic a different way. So those of us plugging in values here, give me some to start with. If we do 1/5, you're using fractions to transform, and some people hate that. So I might just do nice whole numbers. So let's always start with a 1. What's log of 1?
0.
0. Let's plug in a 5. What's log base 1/5 of 5? If we reciprocate it to a 1/5, it's a what? Negative 1. And that's enough. We actually only asked for 2 on the graphs, but we need 3 for this assignment. So let's do another one that would turn out nice. 25 is a nice one. So if I do a log base 1/5 of 25, and then I can rewrite that as a 5 squared, and then I can rewrite that as a 1/5 to the negative 2, what's my answer? Perfect, there's my values. So now when they ask for your mapping, now the part that's like on there, your guys' x and y's map onto what? What's the mapping? X's will move where? -3. Y's will we'll negate them and then we'll move them down. So now when we do our list of new values, and I have all my new values, I'm going to just do it as a t-chart. I think my key has them as ordered pairs, but I'm just going to do it as a t-chart. So I should have just done it like this in the first place. All right, let's move all of our x's down 3. Again, do you see why some people don't do the fraction one? Because now you're working with fractions. So we use nice whole numbers. 1 minus 3 is -2. 5 minus 3 is 2. 25 minus 3 is 22. I sure don't want to plot that on a graph though. Like, that's why we kind of let you do the 2 values, because that's a mess. All right, let's negate my 0 and then minus a 2. Let's negate my already -1. So what does that make it if I have a negative, but it's already a -1? A positive 1, right? And then minus a 2. So did you guys get a -1 when you found it? Okay. Let's negate my -2 and then go down 2. Did you guys get a 0? Perfect. And there's our mapping. That's how you do that part. You guys okay with mapping? I'm just getting comfortable. Okay, let's do ones that just ask for domain, range, and asymptote. Okay? So we're going to move down to the next set of questions, numbers 10 and 10 through 13. Which one do you guys want? Do you want one that shifts horizontally? Do you want one that doesn't? How do we know if it shifts horizontally?
13.
Okay, 13. I think 13 is a good one because everybody wants to move the asymptote, but does 13 move the asymptote? No. Right? Let's do it then. So because everybody sees this plus, we won't always have parentheses, so you've got to kind of make sure you're kind of paying attention. But we want to know domain, we want to know range, and we want to know where the vertical asymptote is. And to be honest, I like to find my vertical asymptote first because it directly affects my domain, right? Okay, first off, what's the easy answer here on logs? That's always going to be on every single one of them. Yeah, 0 work, right? Because we know range is all reals. Just like how an exponent's the domain is all reals, this one's range is going to be all reals, okay? All right, let's decide where the vertical asymptote moved. Did my vertical asymptote move? Does that +1 affect my asymptote, or is it separate?
Separate.
It's separate. So this is all I look at for my domain. I want to make sure my x stays above 0. That's it. That's how easy it is. It did not shift anywhere. So it's a lot like the parent function at x equals 0, and my domain is 0 to infinity, or x needs to be above 0. It's not bad, huh? So you guys can calculate that. Now, we would take all that and put it together in a graph. Do you guys want me to shut up for 5 minutes, or should we hurry and do a graph? Sorry about the ACT prep cutting into this, but do you guys want a graph before you go, or are you guys checked out? Raise your hand if you feel like doing a graph together, because I will do it. You want one type? Okay, the rest of you, if you don't want to anymore, you are welcome to just work on your own. Otherwise, I'm going to do it. Is there one that stands out to any of you that you want me to try on our graphs? I think 20 is a doozy. You guys want to try that?
Sure. On
this one, I think I kind of prefer when my bases are fractions, like plug-in values, to be honest. But we'll see how the mapping goes. I don't love this one. This one is really, really tough. It has a lot going on. But it's a good one to do together. Okay. And if the bell rings and we're almost done, we'll just kind of stop where we end. Okay. Let's do it. All right. When we go to graph, if you guys look at the instructions, I just wanted to make sure the asymptote was clearly shown, and we really only asked for 2 points. So you don't have to go crazy with the 2 points, but we do ask for the domain and range, okay? So let's get our vertical asymptote so we can easily state the domain and range, and then let's just make sure we have a couple points. All right, what do you guys notice is happening on this one and getting my shift? Right.
X
Yeah,
minus 2.
X equals -2. So I shifted here. That means my domain is what?
-2 to infinity.
Yep, -2 to infinity, and we are so used to our range being all reals. Okay, we found a huge part of this. Now, listen how easy this could be. You guys do not have to do the mapping. You could just plug in some stuff here, but remember how we're strategic. If you're going to choose to plug in points, you can no longer, you have to take into account there's a +2. So if I want a 1 inside, what would I plug in, actually?
It would be 3.
I'd plug in a -1. Really good job. I would plug in a -1. And then if I wanted a 6 inside, what would I plug in? A 4. So those are my strategic plug and chug way, if I chose to do that way. Now we're going to run out of time. Let's at least get a visual of where it's at. And then those of you who want to map maybe your parent function, like a log base 1/6 of x, and then you guys map, we'll at least hurry and write down the mapping, and then we'll probably be out of time. Okay? We are visualizing so this function was a 1/6, right? That went like this. But because it's negative, it's going to what?
Do that.
Yep. Because it's a 1/3, it's going to flatten a little. And because it's left 2, it's over here, and it's down 5. So we're visualizing this. Does that make sense to everybody? We're visualizing it being down there. Okay? If you're going to map, you're going to generate your parent, and then you're going to move your x's where and your y's where.
It would be -2 on
Left 2?
and then -1/3 and -5.
Exactly. Those of you who want to map, boom, you should end up down there when you're done. Those of you who just wanted to pick 2 strategic points, I hope you get them down there as well. And I'm going to let you guys kind of finish that one on your own. You guys are awesome. You have 4 homework problems done. I hope that makes